What makes a computer tick? At their core, all our devices use bits, simple on-off switches, ones and zeros. These bits power everything from video games to scientific research, but even the fastest supercomputers hit a wall with certain problems. Enter quantum computers. Instead of bits, they use qubits. Think of them as dimmer switches that can be on, off, or both at once, thanks to superposition. This lets quantum computers explore countless possibilities simultaneously, like solving a maze by trying every path at once. They also use entanglement, where qubits become linked, allowing them to solve problems classical computers can't touch. Today's quantum computers are still in their infancy, but they're advancing fast. Their potential is staggering. New medicines, revolutionary materials, and answers to mysteries of the universe. But there's a catch. The same power that makes them so promising also makes them a threat. Quantum computers could break the codes that protect our digital world. Our current security was built for classical computers, not machines that can try every key at once. The quantum threat isn't science fiction, it's a looming reality. As quantum technology grows, so does the risk to everything we keep secure online. The question isn't if quantum computers will change the world, but when, and whether we're ready. This is the dawn of the quantum era. We protect our digital lives with encryption, secret codes that scramble our data so only those with the right key can read it. These codes rely on math problems that are easy to do one way, but nearly impossible to reverse, like multiplying two huge prime numbers. Classical computers would need longer than the age of the universe to crack these codes, but quantum computers, using algorithms like Shor's, could break them in minutes. Suddenly, the locks on our bank accounts, emails, and even critical infrastructure could be opened by anyone with a quantum machine. The foundation of internet security would collapse, exposing everything from private messages to national secrets. Imagine a world where nothing online is safe, where trust in digital systems vanishes overnight. The quantum threat isn't just about speed, it's about making the impossible possible. If we don't adapt, our digital locks will be useless. The stakes couldn't be higher. Quantum computers could shatter the promise of online security. You might think we're safe until quantum computers arrive, but the threat is already here. Hackers and hostile nations are stealing encrypted data now, storing it for the day quantum computers can crack it. This harvest now, decrypt later strategy means secrets stolen today could be exposed years from now. Health records, business deals, government secrets, anything meant to stay private for years is at risk. Once quantum computers are ready, all that stolen data becomes readable. The damage won't just be future tense, it's happening now, as sensitive information is siphoned off and stockpiled. We're in a race against time, but we don't know how much time we have. Experts say quantum computers could arrive in 5, 10, or 15 years. But the clock is already ticking because the data is already gone. Waiting for quantum computers to appear before acting is a recipe for disaster. The only thing protecting today's stolen data is a lock with an expiration date. The quantum threat is urgent, not distant. We must act before it's too late. If our current locks are doomed, what's the solution? Enter post-quantum cryptography, or PQC. PQC is about building new encryption methods that can withstand both classical and quantum attacks. These new algorithms use different math, like lattice-based cryptography, which is tough for any computer to solve. NIST has led the charge, standardizing PQC algorithms like Crystal's Kyber and dilithium in 2024. This gives everyone a blueprint for quantum-resistant security. But inventing new locks is just the start. We have to install them everywhere. Servers, laptops, even smart devices. Upgrading the world's digital infrastructure is a massive job, but it's underway. The transition will take years, but the race has begun. The goal: replace vulnerable locks before quantum computers arrive. Our digital future depends on it. Governments and tech giants are finally taking the quantum threat seriously. The US and Australia are mandating quantum-resistant security for critical systems, but most organizations aren't ready. Many don't even know about PQC. Treating quantum as a distant problem is dangerous. The threat is already here. Every organization must identify its sensitive data and start testing PQC now. This transition takes planning and time. Waiting until Q-Day is too late. Securing our digital world is a shared responsibility. Governments, businesses, and individuals all have a role. The window to act is open, but closing fast. We have the tools and the warning. The time to build our quantum-resistant future is now.